Let's take a look at chapter 2. I'm not going to do much with this. We have perfectly good videos for you to watch. You don't have this book yet, do you? Sorry. I'll put that to you right now. All right. Anybody else not have this? If you forgot yours at home, I can give you another one. Give me the other one back next time. Oh, it's Yibo! Hi, Yibo. You have nothing to apologize for. It's sheer laziness on my part that I haven't learned Chinese by now. And Urdu and Korean and how many languages are in this school again? Somebody counted like over 20 at one point. So anyway. Nice to see you, Yibo. Let's talk about 2.1. Let's talk about radical functions. Now again, there is a, oops, because I bang into the camera. There's a perfectly good video that you can watch without me. I don't need to do it here for this lesson. How many people have watched the 2.1 lesson already? Oh, good. Most of you. So that means you'll know what I'm talking about. That means we can go to, let's go to just example 5, just to make sure. Now, the first thing I want to point out to you, I don't remember how good a job the video does of this, is that in chapter 1, this is our formula. Let me make sure I write it down properly this time. There. Oh, see, I goofed it up. I forgot the F. There we go. Right? Please notice that this is very, very similar, right? This is almost the same thing if you really want to think about it. The A was my vertical stretch. That's what this is. My B was my horizontal stretch. That's what that is. My H is horizontal shift, so is that. My K is my vertical shift, so is that. So in the grand scheme of things, this formula is really that one, except that I know specifically the function is the square root function. And it's like, well, why? It seems like this is the opposite of the way we usually do math. Usually we do math where we start with something specific and we generalize. Here we started with something general and now we're going to a specific. That's because these things do have kind of some quirks about them as square root graphs that you need to kind of explore. So actually, I think now that I think about it, I might just do example 4 and 5. So let's take a look at example 4 first. So let's work through this together and make sure that we understand what's happening. Now, a normal square root graph, right? The parent function of all square root graphs is y is equal to the square root of x, which is a graph that goes through 0, 0. And then, if I just wanted to count by whole number dots, 1, 1 is definitely a point because the square root of 1 is 1. 2 as an x would be an irrational number, so I don't want to count by that. I'm going to jump to 4 because the square root of 4 would be 2. So 4, 2, and then here, make a bigger dot. There we go. 4, 2 would be a point. What's the next place where I know for sure I'd have a whole number for y? 9. 5, 6, 7, 8, 9 would be up at 3. So something like that. And there we go. So that's the parent function. So every time I do one of these examples, I'm looking and I'm comparing, and I'm comparing this to what that was. What is the parent function? So, first things first, the square root of 0 is 0, and you can't, and if I start here at 0, 0, any stretch of 0 is meaningless. We just learned that in our last quiz. So, H and K have to be here. The coordinates of this vertex point have to be H and K. So I already know that H is 2 and K is -1, right? Because we shifted 2 to the right. And again, maybe if you want even, you could just put in sort of dotted line the parent function. So 4 would be 2, so about there maybe. And once again, I've missed the dot that I drew. There we go. There. So do something like that to give yourself a nice little heads up. Okay, now how do I find the vertical stretch? Well, here's what I know. On my parent function, vertically, from this first whole numbered point to that one, it's a vertical travel of 1 unit. how far do I have to go from this point to this point? 1 unit. There's no stretching going on. Okay? How about horizontally? To get from my first whole number to my second whole number is again a shift of 1. How far is it from the first whole number, or whole integer I should say maybe, to the next whole integer? Still 1. This was an easy one. No stretches. Okay? So I know that either y equals, oh, wait a minute, I forgot something.
A has to be negative.
Yeah, where are we reflecting? Because we're going in a different direction, so obviously we reflected. But which way did we reflect? We reflected over the y-axis. How come it wasn't the x-axis? Because if we reflected over the x-axis, it would be, first of all, down here, and it would be heading towards positive infinity for x. It's definitely heading towards negative infinity. It was a reflection in the y-axis, so that would be which one? Which one of these is the negative number now? B is negative 1. So there we go. Sorry, I forgot about that. So y equals, a is 1, so I'm not going to bother even writing 1. F of negative 1, and again, I don't need a 1. I know there's a 1 there. X minus 2, and then minus 1, right? Or, what if I didn't want, it just says determine the equation. Well, that's an equation. That's a function form equation. What if I wanted the specific equation? Right? Kind of like that. What if I wanted the specific equation with the actual square root in it? Then I would want y equals the square root of, again, a doesn't exist, or a is 1, I should say, x minus 2, and then minus 1, right? So there we go. Those are both the same thing. Now, would it mess with you if you were doing your homework, this was your homework, and let's say this was the answer key. Say they wanted the specific function, or the specific equation, not the function form equation. What if they actually had this for an answer? Oh, there. Do you get that that's the same answer? What have they done? Looks very different to me, but it's the same thing. Can you see why it's the same thing? It's factored form here. Remember that the basic form of all our formulas is in factored form. So if it ever said, or again, if it was multiple choice and this wasn't the choice but that was, you'd know that's your answer. Or if it ever said, give us a simplified equation, they kind of mean this. Simplified means get rid of any brackets that you can, do any operations that you can do without doing any fancy algebra. So I could see that being the answer. Question?
Okay, I was just going to say, I had like that sort of as my answer for one of the questions in the homework, and I was just wondering if that was right or wrong.
I'm going to tell you, what did the answer key say?
It was factored.
Yeah. So in other words, did the instructions say to simplify? No. So it was the factored form, so you're done. Don't factor it unless you have, or don't expand it into unfactored form unless you have to. Right? I wouldn't, if the question was, this was my homework, I'd have stopped there. Unless the actual question said, simplify your answer. Or, if it was, again, multiple choice, and this wasn't the choice. Right? Because I'm pretty sure I did that right. What's wrong here? Then try expanding that bracket and see if you get the choices. Okay? Now, I'm giving you a very specific situation here. To be honest, I don't remember. Actually, this is a very small unit. This hasn't even been on every single provincial exam we've done. And I honestly don't know if I remember anywhere a kid would be here, but this was the answer. But I've seen it in the homework, and I've certainly seen it in the curricular material. They point out that, yes, students need to know that this and this are the same thing. So that's kind of why I'm taking the time to talk about it. And I don't think in the video, I think in the video they just stop with those two things, right? So I wanted to just make sure that I pointed that out to you. All right. You want to try these ones yourself?
We had to.
Oh, that's right. You actually already did these as notes. Okay, so never mind. You've already done these. Okay, then you know what? I think maybe what we'll do is we'll just let you guys have some time to try 2.1. If people are stuck on, I'll leave the stream open. If there's anybody at home who actually has any questions that's like, I'm trying to do this 2.1 homework and I'm stuck, just pop into the chat and tell me what question you want to talk about. When it says sketch the graph, I don't know if you noticed my beautiful sketch I had going on here. Check it out, where I had to make the dots so big that you could see it from space because I was drawing such a bad line. You'll notice that when it says sketch, I don't really need anything too fancy. Having said that, it's really nice to do these on graph paper if you have it, because it's just easier to organize and count on graph paper. So if you have graph paper, it's not a bad idea to do number 3 on graph paper. If you don't, see if you can do better than that, but don't try too hard. Lynn? Yep. Sure. So we got some guys here who have already started the homework. Let's do 4D. Ready? Okay, I'm going to just do 4D right under here. I've got some space. What was your question? Yeah, go ahead. Okay, so 4D. The vertex. Again, I'm going to draw my parent graph. Oh, parent graph. Oh, I'm just sorry, being a perfectionist for this one after the last one was so ugly. There's my parent graph. Okay, vertex tells me H and K. H is move 3 to the left. K is move 1 up. Do you agree with that? Okay. Now, on the parent graph, to get from my first dot to my second, and by first and second, it's like, isn't there infinite dots from here to here? Yeah, but the first and the second dot, those 2 dots are the only integers. Because remember, when you square root things, you don't get a lot of numbers you square root that turn out to be integers, just your perfect squares, right? So square root of 1 is 1, square root of 0 is 0. The distance from here to here horizontally is 1. The distance from integer to integer on this graph is 1, 2, 3, 4. So a distance of 1 horizontally became a distance of 4 horizontally. So I think my B number is 1/4, right? The number I would times x by. Man, I'm getting a lot of blank stares in the room. There's some people who haven't tried this for themselves yet, right? Okay, so feel free to tune me out and just try. If you're still up at number 1, go back, okay? But for the guys who have tried this, do you agree with what I'm saying? Now, is there a vertical stretch? I don't think so. Because again, vertically, it takes 1 unit to go from integer to integer. Vertically, it takes 1 unit to get from integer to integer. I'm good. I think this is y equals a is 1, the square root of 1/4 x plus 3, because remember it's minus minus 3, plus 1. Now, here's some daring do for you. Is that the answer key's answer? Is the answer key's answer this? Negative. Oh, same thing I did in the other one. I forgot the stupid flip. Okay, which way did we flip? Did we reflect in the y line or did we reflect in the x line? It flipped. This is going to look really great for the people watching on cam at home. It flipped this way, right? So it reflected in the x-axis, which puts a negative out here. There we go. So, sorry, a is actually -1. There is an a. It's a -1. My bad. Forgot about that. I was so busy worrying about this. Is this what they say for the answer? Can I point out to you that that and that are the same thing? We're going to go back. We're going to go back. Lynn, we're going back to grade 10. Close your eyes and pretend everything's okay and it's 2018 and we're in grade 10 and life is good. And I asked you to simplify that. What would you do?
Multiply it by some.
No, that would be when you're trying to rationalize a denominator. I just want to simplify that.
25 times.
Yeah. To a mathematician, that's not the simplest way to write that number. This is. How did we get that? We realized that this has a perfect square of 25 in it, right? So, looking at this, a quarter is a perfect square. So x plus 3 isn't, at least I don't know that it is. So this part of the number can come out of the radical. Now, if I was giving this to you on a test and you left your answer like that, I would totally mark that right. But once again, what if it was multiple choice and you got that answer and it's like, I don't see that answer. But that answer's there. Yeah. Curses. Curses them and their tyranny. Their villainy. Okay. Did you actually have this answer then? The one above my finger there?
I thought if I wrote down that it had a reflection on the x-axis, it went up 1 and went up 3, but I didn't get the...
You didn't get the stretch. So do you see how I'm getting the stretch? It's a count from integer point to integer point. So to get from, on the parent graph, on a regular y equals just good old square root of x, no other transformations, it takes 1 horizontal unit to get to the next integer. But on this graph, it takes 1, 2, 3, 4 horizontal units. So my x numbers got times by 4, which is the same thing as the b number being a quarter because of opposite rule. Okay, and I don't know, I call it opposite rule because that's the way my head works. I am fully aware that multiplying by a reciprocal is not truly the opposite. But okay, it's opposite enough to me. Semantics. All right. Anything else in 2.1 that you've tried and it's not working out? That's about as hard as it gets. I don't think on a test I'd give you one that's any uglier than that. And like I said, unless I was giving you a multiple choice and trying to mess with you, I'm perfectly happy with that first answer. That's a good one. Okay? All right, I think I'll turn off the stream. And let's see, how many people are in the stream room right now? Oh, stream room. There's 5 people in here. I don't know if there's actually 5 different people or if I'm one of them. Maybe there's only 4. I think I count as one of them, eh? So there's 4 people in the room. Okay, so there we go. I'm going to end the stream. Bye-bye, everybody who's watching. End. And now